Assalamualaikum warahmatullahi wabarakatuh to the panels. My name is Nurul Anis binti Jamikun from AS253682. Today I will present to you about my final year project entitled Characterization of Latent Fingerprint Powder from Plant Sources using Fourier Transform Infrared Spectroscopy. A bit introduction. In crime scene, fingerprint has become one of the best pieces of evidence due to its uniqueness and permanency. This is because no two persons yet to be found have the same fingerprint pattern. There are three types of fingerprints, which are plastic fingerprint, pattern fingerprint, and latent fingerprint. But the most common type of fingerprint that have been searched by the forensic investigator is latent fingerprint. Latent fingerprint is a print produced from oil and sweat secreted by the glands when someone in contact with the surface. Latent fingerprint is invisible and cannot be seen by naked eyes. Thus, the prints need to be enhanced first using some method. Fingerprint testing using black powder is the most traditional and easiest way to visualize latent fingerprint, where the fingerprints will be undergo further analysis to determine the types and the minutiae. However, commercial black powder contains heavy metal and high amount of carbon, which can lead to health effects to the users. Other than that, sometimes the image quality of the fingerprint using fingerprint powder does not satisfactory enough to visualize the fingerprint. The price of the powder, which is expensive, also be a problem. Thus, the significance of this research is to introduce to the new fingerprint powder produced from organic and natural sources, which is free from heavy metals, safe and cheap. Besides, it's also beneficial to determine the quality of new fingerprint powder so that it can produce better enhancement compared with standard black powder. The objective of this study to examine the effectiveness of pyrolyzed plant sources as the substitute to fingerprint powder using video spectral comparator, and to characterize the composition of pyrolyzed plant powder using Fourier Transform Infrared Spectroscopy. The study to find good quality powder as a substitute to the commercial fingerprint powder have been done by many researchers. However, most of the powder that have been used is a kitchen-based powder, such as cocoa powder, flour, turmeric powder, chili powder, and baking soda. The study of using plant sources as powder or less. This is a bit review on how the performances of the plant-based powder to a fingerprint on a non-porous surface. Some of the powders, such as durian seeds and mustard oil soot, produce good quality since the prints can be observed clearly. However, for gambir and marigold powder, there are some limitations to enhance the fingerprint. In my research, I used 5 different plant sources, which are coconut shell, oil palm frond, palm kernel shell, rubber seed shell, and areca nut. First, the sample was collected and cleaned from dust and dirt and were dried under sunlight to remove the moisture. The sample was then being crushed and ground to produce smaller pieces of samples. Then the steps were continued with pyrolysis process and the char was collected. All the samples were ground for the second time and sieved to gain a very fine powder. Fingerprint testing was applied onto fingerprints from 3 different individuals and then was analyzed using video spectral comparator. Lastly, all the samples undergo Fourier Transform Infrared Ftir spectroscopy analysis to identify the functional group of the sample. The effectiveness of the powder was determined by analyzing the quality of the fingerprint using grading method. Firstly, the fingerprint sample after dusting was analyzed using VSC and observed under normal and UV light. Based on the results, the fingerprint under normal light has better image compared with UV light, which I assume that the fingerprint might be shine, but it's not. By adjusting the brightness, contrast, size, and focus of the normal light, the type of the fingerprint and the minutiae was then identified. The number of the minutiae was counted, and based on the quantity of the minutiae and the condition of the fingerprint was graded from 0 to 5. From the average of the grading, the quality of the fingerprint can be determined, thus showing the effectiveness of the powder. The analysis was further using transmitted Ftir analysis. The raw and parallel sample will undergo analysis to determine the functional group that can be found before and after pyrolysis process. By comparing both spectra, there are some similarities of functional group that can be found, such as hydroxyl group and methoxy group. The spectrum of raw sample has more intense peak compared with pyrolyzed sample, while the spectrum of pyrolyzed sample was broader. This might be due to the high temperature during pyrolysis process, which caused the chemical compound to decompose. In conclusion, sample 5, which is arecanite powder, showed the best effectiveness since the prints were clearly observed and the minutiae obtained is more than 8, made it fell into grade 5 in average. The lowest quality of the fingerprint is sample 2, which is all palm front, because the print was smudgy and made it hard to analyze the minutiae. From the IR analysis, there are similarity of functional group that can be found in each sample, which are OH group and CO group. This is because plant is made up from lignocellulose compound, which has high amount of OH and CO group. That's all from me. Thank you.